Yesterday we practiced doing the transformations with our quadratic equations. So this is lesson 9.3, transformations of quadratic functions. We're going to go ahead and actually do the lesson that goes with this afterwards. You'll do a worksheet that goes with it, or not a worksheet, I'm sorry, the bookwork. So look in your lap for the bookwork. Okay, so we're going to talk about transformations, translation, dilation, reflection, and vertex form. So first thing is we're going to describe how this graph is related to the graph of f of x equals x squared. Remember yesterday we talked about y equals a times x minus h squared plus k. A is the stretch or compress, so this makes it wide or narrow. H is the one that moves left to right. And K is our up-down. Okay, so this equation, g of x minus 4, this is in the parentheses, so this must be the h. If that's a negative 4, then we're going to move this. The graph will be moved 4 to the right. Remember, it goes the opposite direction of what the sign is here. This one has a number in front. That's a. And then this is our k. So this one is going to go up 1. And then it's going to be reflected over x-axis. So it'll look like that. And then it's going to be stretched. The last one is going to be stretched. This is our stretcher. Plus 1 means we're going to go the opposite direction, left to right. So we're going to go opposite of the positive. We're going to go 1 to the left. And negative 4 means we're going down 4. This is the summary of everything we talked about yesterday. So as you do your homework or as you are taking notes and can't remember things, and come back to this page and look at it. Pause the video if you need to study it a little bit more. This one, what's the equation for this function shown in this graph? So first thing we should notice is the vertex is 2 below the origin. This is a transformation of the parent function, which would look like this. So it's being shifted down 2. That has to do with the k part of this. So here's a down 2. Here's a down 2. So we can cross off B and C. And then we have a negative 3 in front. That would be a reflection. So this can't be D. So it has to be A. Okay, try this one. Pause the video, see if you can do it, and then come back. So the answer to this one is it's reflected. So because it's reflected, the A is not going to be positive. So B and D are crossed off. And then from the origin, this one up 3, that would go with a plus 3. So C has to be the one. So this is vertex form. X equals H is the axis of symmetry. HK is the vertex. I told you yesterday it helps us, the vertex form helps us graph things very quickly. A gives us information about the direction and the width of our graph. So for this one, here's some examples. Number 1, y equals 3 times x minus 2 squared plus 5. What is the vertex of this one? So you go over here, this is the H, this is K, but H is still hard-headed, so you take the opposite of that. The vertex is at 2. The 5 stays the same. So this is the vertex. So what if I had another example is y equals x minus 3 squared minus 2. What's the vertex for this one? Find the h. It's got a 3 in there with the x at x minus 3, so this has to be a positive 3 and a negative 2. Okay, so you're just looking inside the parentheses, but what do we do if there's not a parentheses? So my next example is y equals x squared plus 1. There's not a number in there with the x, so that's a 0, no parentheses. And then the k is 1. Okay, then number 4, what if k is gone? So y equals 4 times x minus 2 squared. Well, if k is gone, we just put a 0 right here. And then kh is just going to be the opposite of negative 2, so it's 2, 0. What if I have y equals 3x squared? There's no h, no k, so that's the vertex. So that's how you do with these. Remember that h is always opposite, it's hard-headed. Now we get to the work of these. So we're going to write a quadratic function in vertex in standard form containing these 2 points. One of them is the vertex. So this is our h and this is our k. It's going to go into this formula for h and k. This is x and y. It's an x and y value that's in whatever the equation is that fits in that equation. So what we're going to do with this is I want you to think about putting everything all in. So you have to be all in to find a. Okay, so by that I mean take this y equals ax squared minus h. Sorry, y equals a times x minus h squared plus k. You're going to put everything you know about it in here. We're going to put the vertex in. We're going to put the x, y point in. So y is 1. The next thing is a. We don't know what a is. That's what we're trying to find. X is negative 4. H is negative 2. So we put minus, and instead of h, you're going to put a negative 2. That's probably the trickiest part of this, is knowing that if h is negative, you have to put it in like this, or remember to switch the sign. And then we put in plus k, which is 5. So now if I simplify, this is 1 equals, so I'm going to start here inside the parentheses, a negative 4 minus a negative 2 is just going to be hold on, lost my place. It's just going to be a negative 2 and then plus a 5. So we've simplified the parentheses. Now we do the exponents. 1 equals 4a plus 5, because negative 2 times negative 2 is 4. Then I'm going to take away 5 from both sides and get negative 4 equals 4a. And then divide both sides by 4. Negative 1 equals a. Cool, we got negative 1 equals a, so now we're going to go and write the equation. Write the vertex form. This again is the vertex form. That's vertex form right there. So we want to write this equation because it makes it easy to find the vertex. That's why it's called vertex form. So when we write vertex form, we're going to write y equals our a. Well, now we know the a, it's negative 1. X we leave alone. Minus negative 2 plus 5. So this one requires a little bit of simplifying. Y equals negative 1 times x plus 2 squared plus 5. So that's a vertex form of this. To find the standard form, what you're going to do is you're going to take y equals negative 1, x plus 2 squared plus 5, and we're going to multiply it because what we're looking for is y equals ax squared plus bx plus c form. So we're going to simplify this, get rid of all the parentheses. So this is now y equals negative 1. Take this x plus 2 and the x plus 2. Multiply those out. So first thing, parentheses. We've got to take care of these parentheses. We're going to get rid of those by multiplying. I'm going to leave the negative 1 alone. Do FOIL on this part right here. So put a parentheses. The result of FOIL is x squared plus 4x plus 4, or it's a perfect square if you know what that is. Keep the parentheses around that because that negative 1 has to be distributed in. And then you're going to add 5 to it. So this will be y equals negative 1x squared minus 4x, and then simplify to make that plus 1. So this right here is standard form. If you want to check your work on this, it's really easy to do if you do this on the calculator. So to check, you're going to go and put one of the equations in y1, go to y equals, put one of the equations in y1, so maybe y1 is the vertex form, y2 is the standard form, and then you're going to graph. So when you graph it, if you did it right, you should end up with 2 overlapping graphs. I thought I had it on here. 2 overlapping graphs that look exactly identical to each other. And then you can also go to the table and make sure that the 2 points that you started out with, those 2, are on your table. And if you did it, then you got it right. Okay, I'm going to have you figure this one out. When you're done with this, your vertex form should be y equals negative 1 x minus 5 squared plus 8. And your standard form should be y equals negative 1 x squared plus 10x plus minus 17. Okay, so I want you to go and try this and check it out. See if you can do it. If you can't get it, then ask 3 other people. Ask your teacher. Ask around. Get it figured out. All right, you guys have a great day. Bye.